Hello friends and welcome to Chemistry by APM. In today's lecture we are going to discuss some of the very important reaction in chemistry with reference to upcoming board examination for the 12th science in chemistry. So in today's lecture and onwards we are going to discuss a very important reaction in organic chemistry, especially for the chapters of organic chemistry in 12th syllabus, which are covering your 25 marks. All these important reaction we are going to cover in subsequent and upcoming lectures. So let us turn with the first chapter of the 12th, which is the very one of the important, that is the chapter number 12, the halogen derivative. In this chapter, you are going to have the five important name reactions, which we are going to cover in this video lecture. First is the Finkelstein reaction. Second is the Schwarz reaction. Third is the Woods reaction. Fourth is the Woods-Fitting reaction. And fifth is the Friedel-Crafts reaction, which is an electrophilic substitution reaction. If you are going to see all the video lectures upcoming after this 10 chapter, the 11th, 12th, and 13th number chapter as well, you are going to get at least 25 marks in best way. So let us start with the very important chapter number 10, that is the halogen derivative and these five important reactions. So here is your first reaction, which is the Finkelstein reaction. Very simple reaction. So if the question asked in the examination, you are supposed to write the what is the Finkelstein reaction in theoretical manner and supposed to write down a reaction as such. So what is the Finkelstein reaction? It is an a alkyl iodide are prepared by the treating a alkyl chloride or bromide with a sodium iodide in methanol as a or the acetone as a solvent. So this is you are going to see here. This is just a halogen exchange reaction. The sodium bromide or the sodium chloride precipitate, which is formed as a byproduct of this reaction, can be separated by the filtration. So these are the one of the characteristic of reaction. So you have just to write when R of Cl is treated with the NaI in presence of acetone or methanol as a solvent, you are going to get R of I and NaCl as a precipitate or byproduct, we can say, of this reaction. So very simple and very easy reaction, Finkelstein reaction. Next reaction, which is the Schwarz reaction. So again, it is one of the halogen exchange reaction. You can carefully observe R is here, R is here as well. Cl is here, Cl is replaced by the fluorine, that is just the halogen is get replaced. And here is the F get position of Cl and Cl get position of F in the product. So alkyl fluoride are majorly prepared by the heating a alkyl chloride or the bromide with the metal fluorides such as metallic fluoride you are supposed to use here as a reagent AgF, Ag2F2, AsF3 or SbF3 are the one of the best we can say the reagent for the Schwarz reaction. When alkyl chloride is treated with the metallic fluoride, you are going to get the alkyl fluoride and the remaining metal plus chlorine, that is the salt of that compound, is obtained as a byproduct, which is the precipitate. Once again, the one of the characteristic is that you can obtain the product by just by the filtration. You are going to remove this byproduct. So this is the one of the easiest Schwarz reaction. Next, simple reaction, very famous majority of the time in the many of the board examination as well as the different boards examination, this reaction is asked for the 3 marks. So here is the when in the Woods reaction, when the alkyl halide is react with a metallic sodium in presence of a dry ether as a solvent. See, dry ether is in liquid state at room temperature, it's not a solid. So when alkyl halide, when we are treating with a metallic sodium in presence of dry ether, you are going to get formation of an a alkanes containing a double the number of the carbon atom present in the alkyl halide. So twice of equivalent of R of X and twice equivalent of sodium metal treated with the dry ether, you are going to get the R bounded with R. That is the choice of this R. If you are going to get the 4 carbon here, you are going to get 8 carbon containing alkane as a product. And again, the byproduct is the same as the previous reactions, choice of a sodium halide. So example is here 1, 2, 3, 4. three. You are going to have the three carbon with the bromine, that is the bromopropane, and another reacting partner is the methyl bromide when treated with the sodium metal in presence of dry ether. See, this is the one of the cross one. If you are going to have twice equivalent of this only, you are going to get the product one, two, three, three and three, four, three and three, six carbons in the product. So one of the product is the for this. If you are going to get twice, you are going to get one, two, three, four, five, and six. That is the hexane. If you treat only this in twice equivalent with the sodium metal in dry ether, you are going to get the formation of the ethane molecule. And if you treat 1:1 equivalent of this, you are going to get this three carbon and one carbon over here in the product one, two, three, four. That is a butane. For this, the product is the butane. For this, only two equivalent product is the hexane. And for this, the product is the ethane. See, the reactions are very easy. Students are not supposed to read and just memorize the reaction. You have just to focus what is actually happening inside a reaction. Writing a product in this case of the reaction is very simple. Just you have to remove this X and Na as a byproduct. You have to write are bounded with this R itself. Writing a reaction and writing a product is a very simple job. Do not make it complicated. Next one is the Woods fitting reaction. It is again similar as that of the Woods reaction. What happened in this reaction? A reaction of an aryl halide with the alkyl halide and the sodium metal. In the dry ether, again, the solvent is same. That is the dry ether to give a substituted aromatic compound. For example, conversion of bromobenzene to toluene. This is the one of the thing I purposefully take it down here because the question is not directly asked write down the Woods fitting reaction. They ask is that gives the preparation of the toluene molecule from bromobenzene. Student will get confused. Do not get confused. It is the one of the simply the Woods fitting reaction. Very important reaction. So here is your reacting partner as the bromobenzene. When you are treated with the methyl bromide in presence of two equivalent of the sodium metal. See, again, the framework of this reaction is the same. This one of the alkyl halide, this is the aryl halide. Again, R of X, AR of X. That is one equivalent, one equivalent. You are going to get treated with the two equivalent of the sodium metal in presence of dry ether. What is going to happen? Removal of this bromine molecule, removal of second bromine molecule from this. You are going to get formation of twice equivalent of NABR salt as the byproduct. What is going to happen? Breakup of this first bond from here and breakup of second bond from methyl group and the bromine from here. You are going to get the new bond, carbon-carbon bond formation between the carbon of the benzene ring and carbon of the methyl molecule. You are going to get formation of toluene. Majority of the time, the examiner were not going to ask, write down the Woods fitting reaction. They are interested in asking convergence like this, that is the gives the formation of toluene from bromobenzene or the gives the synthesis of the toluene from the bromobenzene and so on. Last and very famous reaction, one of the favorite reaction of the examiner or the paper setter, we can say that is the Friedel-Crafts reaction, one of the electrophilic substitution reaction. Very interesting and important reaction. Majority of the time in the CBSE boards also, this examination, this example or this reaction asks for the 3 marks and so on. So when haloarranes when treated with the alkyl chloride in presence of or the acyl chloride in presence of anhydrous AlC. Anhydrous means there is absence of water. So anhydrous AlCl3 as a catalyst, you are going to get the subsequent products. So two examples I cover here. First is the chlorobenzene 2, 2-chlorotoluene and 4-chlorotoluene. Here reactant is the chlorobenzene. You are supposed to give the synthesis of the 2-chlorotoluene and the 4-chlorotoluene here. So another example is one. The first is the alkylation and second is the acylation. Only the thing is that in alkylation, alkyl group is there and acylation, acyl group is there. That is the carbonyl functionality is there. So here second example is the synthesis of 2-chloroacetophenone and 4-chloroacetophenone from the chlorobenzene. So let's have the look upon the examples here. Here is your chlorobenzene, here is your methyl chloride. You are in the presence of anhydrous AlCl3 as a catalyst of this reaction. You are going to get the removal of this Cl from here the Cl remains intact, and the joining of this methyl group at the ortho and the para position. Again, you are going to see the para product as a major product and ortho as a minor. Similar for this, here is an A. Your chlorobenzene is were treated with the C. Again, the both of the example I have covered here. That is the chlorobenzene. You are going to get the synthesis of the 2-chloroacetophenone. So here is the acyl chloride moiety. Here is here CS3C double bond OCl in presence of anhydrous AlCl3. Anhydrous is again in absence of water. You are going to get the 2-chloroacetophenone and 4-chloroacetophenone as the product of this reaction. One of the very important and interesting reaction. Majority of the time, Friedel-Crafts acylation and alkylation. But this first is the alkylation, second is the acylation. Only the difference is this C double bond O group is here. So both of these examples are very important. They directly or indirectly ask you the question on this very important reaction. So you have to go with this. Thank you for this listening this lecture. And upcoming lecture, we are going to discuss another important reaction from the next chapter, which is the alcohol phenol theorem. So stay continue with this.